Hello everyone. So let us implement some more methods that might be useful. So we are going to implement a function to get the front element, the back element. At function will tell us, okay, what is the element at the ith index of the vector. And the next thing we will do is operator overloading. Okay, so I will show you how this is going to work. So let's say int get front, or simply the method is called as front. So we can return array of 0. Okay, so we are going to return array of 0, and that's it. That's the front element. And int back, so if you want to get the last element, so we know that cs pointer goes one step ahead. The last element is present at cs minus 1, and that's it. Okay, we can also implement the at method. So if we want to get an element at a particular index, we can say return array of I. Okay, and two more methods, one for the size and one for the max size, one for the capacity. We can say return cs, that is the current size, and int capacity, and I can return the max size. So the max size is the capacity of my vector. So that's it, we are done. So when we created this vector, we can also accept the max size from the user. So I can say max size by default is 1. Otherwise I can say max size equal to max size. What I'm going to do, I'm going to I've created this vector object v. I'm going to test this now. I'm going to do vector dot pushback, let's say 1, 2 and 3. So I have inserted 3 elements. So the initial size is 1. Okay, I'm not given any parameter here, so by default it is of size 1. But when I do pushback 2, it is going to double itself. So the vector is going to look like this. And when I push back 3, it is again going to double itself. The new size is going to look like 1, 2, 3 and 4. Okay, so 3 will come here. So if I now print the size of the vector, it should be 3. And if I print the capacity of the vector, it should be 4. And suppose if I add 4 as well, then the capacity of the vector should be 8. Okay, when I add 4 and 5 both. Okay, so we have space for 4, but we don't have space for 5. So ideally this vector should double itself. So if I say cout v dot size, and if I do cout v dot capacity, we should get a output like 5 here, and we should get output like 8 here. Let's build our code. If we get this output, that means our implementation of vector is correct. So let's see. Okay, so let's run our code now, and we have dot slash vector, and you can see the capacity is 5, the capacity is 8, and the size is 5. That means the growing thing is working. But suppose if I create a vector of size 5 in the beginning, in that case no reallocation will happen. And if I build the code and run again, so both capacity and the size would be 5, because we have initialized this vector with a value 5. Okay, you look at the constructor, and we are taking the max size from the user. But now if I again push an element 6, now again it will double itself, and the new capacity should become 10 after the insertion. And yes, it is going to happen. So that means pushback is working fine. And if I do pop back, and if I now see what is the size of the vector, the size should be 5, but the capacity should be 10. That means the pop back is working fine. And if I say, okay, tell me what is the last element of the vector, so I can say v dot front, and if I say, okay, cout v dot back, the front element should be 1, and maybe let me just say it is 15. The last element should be 15. Okay, so that is fine. This front and last are also working fine. Now we can check, okay, tell me what is present at the second index. So I can say cout v dot at second. We should get an answer that is 3. So we have third element at the second index. that means this method is also fine. So we have tested all our methods. So one thing we would like to do is we would like to print all the elements of this vector. So we can say for int I equals to 0, I less than v dot size I plus plus, and here we can do cout v dot at I. Okay, and maybe we should put a comma here, and then we should run our code. So we can see 1 2 3 4 15. So these are the elements of the vector, which is correct. And so one thing we can do is we can also add a instead of using the function at, we can do operator overloading. Okay, we are going to define this operator method, that is square brackets, and in the parameters we will tell that this will accept an integer I, and we are going to return array of I for this operator. Okay, so this basically means whenever this operator is called on the object of your class and this operator contains a parameter I, okay, you will return array of I. So now instead of making it like this, we can simply use it like this, v of I, and this is going to work. And if I show it to you, yes, this works. Okay, so that's the beauty of operator overloading. And before we go, one last thing I want to tell you in this is, yeah, so we will talk about some good practices while defining these classes and objects. So let me tell you about these few terms. One is when you are sending this parameter to the method and this parameter or this argument is not changing, it is behaving like a constant in this function. Okay, the value of I is not changing, we are not doing I plus plus or something like this. So it's better to make this variable as a constant. That's it. And we can also have constant functions. For example, the size function does not modify any of the attributes of the class. Okay, so we can also make this size function as a constant function. We can make this art function as a constant function. Okay, and we can write const here as well, and we can write const here as well, and we can write const here as well. Okay, so the constant functions are those which do not modify the empty is a const function. So these are the data members of the class, and all constant functions will not modify the data members. So can I make pushback a constant function? The answer is no. Why? Because in pushback we are modifying the array and that is a data member of the class. Okay, but what we can do, we can make this parameter d as a constant. Okay, because we are not going to change the data inside this method. If we do, we will get an error. Okay, what about popback? We can't make it constant because we are changing the current size. Empty is okay, front is okay, back is okay, at is okay, all of them are fine. And that's it. So yeah, so that's about a good practice that you should follow while writing code, and that helps in debugging, because if you're doing some changes inside the constant function, the compiler is going to notify you. Okay, for example, if I do something like ms++ by mistake here, then I'm going to get a compilation error. Okay, oh sorry, I've not made it const. Okay, now you can see I'm getting a compilation error. So this I can't do, and yes, now it will work fine. Let's run our code, and you can see it is working as expected. So that's the implementation of vector, and that's all for this lecture. Thank you.